Today in the morning, a class 12th student asked me a very common question. If electric current is a scalar or a vector? Now we know scalar quantities are those quantities which have only magnitude, and vector quantities are those quantities which have both magnitude and direction. But there is a nuance hidden in the definition of a vector. What is that nuance? Actually, vector quantities are those quantities which have both magnitude and direction, and also they must obey the vector law of addition. Let's say, for example, uh, we have at a point there are two forces acting. One is F1 is equal to 3 Newton, and other force is acting perpendicular to this force at this point. F2 is equal to 4 Newton. Now, what will be the net force acting at this point? Should we add these two forces algebraically? No. Actually, since force is a vector quantity, we have to follow the vector laws of addition. Here, the net force acting at this point will be under root F1 square plus F2 square plus 2 F1 F2 cos theta. Now, since the angle between those two vectors is 90 degree, and we know cos 90 degree is equal to 0. So, this whole term 2f1 f2 cos theta comes out to be 0. So, we can erase that term. Now, under root f1 square 3 square plus 4 square, it comes out to be 5, and this is 5 Newton. Now, in case, let's say for example, at a node in a wire, electric current is coming towards this node. I1 is equal to 1 ampere. Also, in a second wire, electric current is coming towards this node. Electric current is coming towards this node. I2 is equal to 2 ampere. Now there is a third wire, and in this third wire the current is going away from the node, and we have to find the value of this current I3. Now in class 12, in the chapter of electric current, we studied two Kirchhoff's rules. The first rule is Kirchhoff's junction rule. The Kirchhoff's junction rule states that the sum of all electric currents coming towards a node is equal to the sum of all electric currents going away from the node. So in this case, I3 will be equal to I1 plus I2, and in this case I1 is 1 ampere, I2 is 2 ampere. So it will be 1 ampere plus 2 ampere is equal to 3 ampere. Here, let's say the angle between these two wires is 60 degree. Will it matter the angle between, whatever may be the angle between these two wires? It doesn't matter at all, because electric current doesn't follow the vector law of addition. So once again, is electric current a scalar quantity or a vector quantity? Electric current is a scalar quantity, because even if it has magnitude and direction, it doesn't follow, since it doesn't follow the vector laws of addition, it is a scalar quantity. Thank you.